computer, pin video. Okay, so this is my proposal for an agenda. I made an agenda box after I wrote the agenda. So this is a manual representation of the cell overflow property in a spreadsheet. So we dug headfirst into Git last week, and what we shall do, I propose, is we layer on Git skills 1 week at a time, and by the end, you'll all be Git whizzes. So I would like to introduce the relationship between local Git repositories and remote Git repositories, and get us all set up to make sure that we can get our icon projects up to a remote and do so without accidentally pushing up the wrong files. So I'd like to also make Git ignores and readmes. So we'll just introduce Markdown ever so briefly. Then we'll see where you are in the icon project. This is our transition day out of the icon project. So hopefully you are at a stage where those are getting fully baked and your brain is ready, because we're encoding in JSON. And then, so here's my proposal. I want to make a project with you live tonight that I've been itching to make, and that I think Python is perfect for, and it fits perfectly with our current state because it's a JSON encoding. It will involve JSON encoding. So I'm trying to experiment with different approaches to class, and one of the approaches might be that I'm going to try tonight is to try to get as far down in a whole project cycle as I can, from conceptualization to tinkering, and I'm going to encourage you to tinker with me live with the code, since these are all skills that we'll then invite you to work on with a JSON project this week. So how's that sound?
Good.
Good. Great. Git, we had Rachel Roth was getting it up, and how many, let's go ahead and raise your hands if you made at least one commit to a Git repository between the end of last class and this moment.
Where's the digital hand again?
It's inside participants, and it's probably in the ... menu.
I tried. I don't know if I did it.
How? Well, that's a great place to be, since it's easy to figure it out. How would you figure it out?
I should be able to go into the my Git projects and do a list all and see if it's in there.
That will not show you commits.
Okay.
You will get there with git log. Git log will say what has been done. So let's all do that. So let's find our way into a Git repository of your choice. I'm using my practice Git that we did with our Python looping. Oh, good. Is it not in? Oh, this was me cloning people down. CD. Okay, so I can do a Git Status, unbranch master, Git log. All right, so did I do commits? My last commit was Wednesday, April 15th at 5:28 p.m. UTC -4, and there's my message. So that would be a good place to start. So with our log, we can see what we did. And remember our basic principle of a Git repository is divided into 3 sections. What are those 3 sections?
One's a staging area.
Yep, so here's staging. So these are ready to be committed to the what?
Working directory.
Negative. Committed to what?
The index.
Yep. So we commit to the index with git commit. What's the flag, Chelsea?
M.
Yep. -m, and then we put a message, and Rachel Roth had a yeah message that got committed, hopefully to be forever enshrined in the interwebs of Git commits. So remember, index is the vault. We never interact with the vault directly. It's like there's always a vault worker that interacts with everything. It's like a safety deposit box where they go and get it from the safe for you and put it in a little room, and then you do your sneaky business and then they take it back. So the vault, we get in there with git commit. How do we move from, what's the thing we are operating in always?
Working directory.
Yeah, so working directory. And so we have, what we did not draw last week, which we want to get to now, is within the working directory, we really have we have two areas. We have the working directory of files that are tracked by Git and untracked files. So untracked files, hopefully by the nature of its name, let me write it more clearly. Untracked files never make it to the staging ground. That's what we mean by untracked, is that they are not going to get scooped up in our command to move to the staging ground, which is what? I actually just told it to you.
Git add.
Yep. And then we will try to avoid taking the shortcut unless we're building a repo. So instead of saying git add dot, we add the files individually until we know exactly what's happening. And we're not going to accidentally scoop up everything on our hard drive, or worse, our boss's hard drive, and send it to a remote. So what we want to do for a little, before we do remotes, is figure out how do we preserve some files to never be tracked. And we do that by making a file inside the Git repository with a name that must be Git Ignore. And we put into that file a list of paths to directories or individual files that we do not want to have committed. And so I'm going to encourage you to use your resources. And the Git resource that I suggest is the Git book. And let's do, if we do a search for version control, the Git basics, undoing things, remotes, tagging, branching, distributed, recording changes, viewing. Let's see if we can do in general, I try, well, that's not good. Wow, they're going to make me go to the internet. It was on there. It was in there. Why didn't it get it to me? Wow. Git ignore specifies intentionally untracked files to ignore. So a Git ignore file specifies intentionally untracked files. Each line of a Git ignore file specifies a pattern. I'm going to chat this out. Welcome those of you that just popped in. We are figuring out how to not track certain files. When deciding whether to ignore a path, Git normally checks that Git ignored patterns from multiple sources with the following order of precedence. Patterns read from the command line, patterns read from a .git ignore file in the same directory, and all the way down through. So patterns which a user wants Git to ignore in all situations generally go in the core pattern format. A blank line matches no files. A line starting with a dot serves as a comment. A backslash in front of the first hash for patterns that begin with the hash. Escape the hash. Trailing spaces are ignored. An optional prefix which negates a pattern. Forward slash is used as a directory separator. So you can get rather complicated. which will be quite fun. And so the pattern hello.splat means any file or folder whose name begins with hello. If one wants to restrict only this directory and not its subdirectories, one can prepend the slash, the pattern with the slash, i.e., but not a/hello Java. Okay, cool. So Rachel Roth had a file. So I'm clean. So I'm going to make a file called don't track me dot JKS, which would be a Java key store. Encryption stuff. You don't want to send your key store up there. So normally, if I would change any file in here, it would automatically get scooped up. So we're gonna demonstrate that here. So I'm going to, if we do a git status, I should see untracked file don't track me.jks. So I want to prevent this from getting scooped up. So I'm going to make a .git ignore file. So I'm going to make a file. I'll do it the way that most of you will probably do it. So come into a text editor, open a new file, and save it in your Git repository as, am I recording? Save it in your repository, Python2 called .git ignore. Thanks. I bought it on my other computer. So in my case, I blink without any special characters, a file name matches itself and only itself in the current directory. So if I have this in my git ignore file, I can also do comments. So I can say this file shall not be added automatically by git add. Okay, so save that. I can come back to my command line and say git status. I should see a .git ignore. And now, if I'm going to go in and change one of these files, jailsum.txt. So this. Okay, so now if I do a git status, I just modified that file, so it's not committed yet. So if I were to run a git add and say add everything that has changed in my current working directory, git add dot, we should, now the question I'm asking myself is I forgot whether or not the git ignore has to be in the index for it to work. So we'll see. Git status. Yeah, so you see it didn't work. So what I want to do first is I'm going to try pushing the git ignore into the tracked world. So I think then hopefully it'll read it. So I'm going to remove those. I can restore them with git or I can take them out of the staging ground with git restore minus staged, and then don't track me. So then a git status. Okay, so that's still untracked. So I can do a git commit right now, and even though it didn't automatically get not tracked, it isn't tracked. Testing git ignore. So now my status is untracked files. And if I make another change to my file, so let's see what it does. I've wrestled with git ignore. I've always gotten it to work, but it always seemed like there was some sort of dark magic involved. It still moved it in. Let's go back to the documentation. Exclude everything except directory, foobar. Is everyone else getting the same strange behavior? Okay, the next thing to try is a leading // meaning this file that's in my current place. So let's remove that again. Still didn't get it. Still slurped it up. This is one that's actually working. Yeah, we just listed the file itself. And then how do we get it to work? Git normally checks Git Ignore patterns from multiple sources. Patterns read from the command line. Patterns read from a Git Ignore file in the same directory path as or any parent directory with patterns in the high-level files. These patterns match relative to the location of the Git Ignore file. Project normally. Okay, so the last thing to try is, I guess the / shouldn't have worked because that would have tried to, it wouldn't know how to deal with that absolute path. So, oh. So let's do Vim. By the way, what I'm using is a tool called Vim. And sometimes if you forget to do a commit, if you forget to do a commit message, it'll put you in Vim, and you won't know how to get out because the way to get out is complicated. You have to hit escape, and then you have to enter command mode with a colon, and then you see command mode down here, and then you have to tell it to write the buffer out and then quit. And that is how you get out of Vim. So that's like the emergency. If you're in an interview and you accidentally forget your -m, colon WQ. That's how you get out. Write that down. Colon WQ. Okay, so let's try this one more time, and then we'll move on if it didn't work. Git restore. Okay, so now, okay, it didn't work. So we'll pick up with Git Ignore later. I don't know what that's a weird thing. But that facility should work after a couple more hours of debugging.
Excuse me.
Yeah.
I'm here to see someone. Where do I go? Here?
There, do a feedback problem. It's just repeating.
Okay, let's get.
So what do I do? Yeah, I don't know the floors.
On the floors?
Yeah, I don't know the floors
You don't know the floor?
and the number. Maybe let me first find out the number on the floor.
Okay.
I think George needs to be muted. Okay. Is that better with the feedback?
Yes.
Yeah, that's perfect now.
Okay, great. So .git ignore is left to be worked on. Now, what we want to think about is there's this thing github.com and several other online Git servers, and we want to start interacting with those. So the thing to remember, I mentioned a little rule of thumb about repositories last week. Does anyone remember how they are related? Is there like a master repository and then everything has to line up with the master? Or is it more democratic?
You have your master and your branches.
Yeah, so you've got branches, and most importantly, the branches could exist so inside your index, all your commits are stored in a tree, and trees have branches. The structure of this repository, working directory, staging ground, and index, is non-hierarchical with respect to other repositories. So we don't want to think about the github.com server as some sort of authority. It's just a server on which a regular old Git repository exists with which you can interact. And there's no such thing as special repositories. So there's no way to designate any repository as more important than any other. The only thing you can do is give instructions for moving information between the repositories. So companies, now it's Microsoft Corporation, run major servers that have on them the Git Server system, which knows how to provide users over a network access to repositories. So here's, this is internet, this is server, and so then inside the server are a whole bunch of repositories. So index, staging ground, working directory. One of those could be yours. And so when you go on github.com and you make a new repository, it cooks up exactly what we did on your home computer. It ran git init on the server, the equivalent of that for the server. And then what many of you have been doing is been dumping into your index on the command, on the graphic interface on the web into your Git repo. And so what we did at the very end of last week was we issued a command on your home computer. So this is you, local. And so we can copy everything with git. What was the command?
Clone.
Yep, so we make an exact copy, and Git Clone can work over a network. Git Clone can work on your own system. Again, there's nothing special about where this repository is, except for that has to do a little bit of network stuff to make sure that we can move those files in a safe and coherent way so we can reconstruct them. So the git clone command brings things down. It makes a copy of everything in the index, and by default, it will only clone down one branch. It will clone down what you designate as the default branch for the server. There's no such thing as a default branch inside a repository. That's something that comes from the server infrastructure for Git. And so once you run a git clone, you have only the vault, and then your working directory is made to look like the recent most commit on the default branch inside the remote repository. So let's all do that. Let's all clone one another. Let's make sure we can clone someone's. Now what would be interesting is if you clone one of your own. because many of you have a workflow. Raise your hand digitally if you have stuff on a GitHub remote server that you don't have locally and you would find useful to have locally. They're in that situation where they've kind of been dumping stuff and it's organized only on the remote. Okay. Well, no one has that situation then. So let's, I believe we have all of our Git URLs linked here, right? Yep. Okay, if your list is not here, who are we missing? We're missing George, Cliff, and I think those are the only two we're missing. So if you need to add a reference here, that's fine. So everyone choose one another. Let's choose a repository of someone else in the class. Anyone have some code that they're particularly proud of from their index or their icon? All you icon makers out there. Quite a bunch tonight.
You can do mine if you want.
Who's mine?
Rob. But you already
great.
did it last week.
Yeah, that's right. We did do yours. Joanne, how about you? How's your stuff looking?
It looks okay. You can try that one.
Oh, good. So choose someone. Could use Joanne too. So remember, I made a special directory for, remember, we'd want to try to not clone into your existing directories. So I know Rachel Roth is lurking inside of her Git repo that we were playing with. So she's going to want to clone into some other place. So how do we check to see if we're in a repo? Stephen?
I don't know. I wanted to ask you that. I don't.
Yeah, Git Status. So if you run Git Status and it says fatal, a Git repository that doesn't exist has no status, not a Git repository. That's a safe place to clone another repository into. So
How do we know that we're, I mean, like, so I look at where I am, and here, let me show it with you. I've got this. I was only able to do so much over the past week.
Yeah, can you make it bigger? I can't see it. Okay. And then so yeah, your root of your file system is not a Git directory or Git repository. That's good. So now you want to do your cd c:" thing again to make it back onto your C drive. And now you can do users/Steve or whatever your name is. There you are. And then that's your home. And then I think we had I can hardly read the text, but I think that's where you had a Git practice somewhere. And so now because you have the testing in blue, that means this is not the place to run Git clone because we want to clone into a fresh place. So cd space your parent, which is ... and then make a new place where you can put these. So maybe make directory Python2 peer repos or something. In fact, I'll do that with you all together. So I'm going to stop your share here, Steve, and do mine. So everyone get a fresh place. So I'm going to say make directory Py2 peer repos. And let me pull this up just in case it's getting cut off anywhere. Is that big enough text-wise?
Yeah, that's good.
Okay, CD, so I'm going to jump in there, Py2 peer repos, and I'm not going to do a git init because I'm not making a new repo. I'm getting someone else's that will already have a .git in there. So this is where I say Git Clone, and then I can paste in the URL of any other repository on a network that I have access to, and it will attempt to transfer all of the objects in the index into the current directory. Cloning, cloning, cloning. It usually doesn't take this long. The suspense is killing me. It's not a good sign. But you're all hearing me. That means that I've got a network connection. GitHub.com, Joanne L-DAT129. Let's just make sure I can see it on the network.
Didn't work for me. It says timed out, failed to connect.
Oh my goodness, you mean you can't get on there either?
Right.
Wow, that means their system's down. That's a big deal. If we're both having it on different networks.
Yeah, mine's just sitting there like that too.
Wow, Bill, get your act together. Come on. It's got $1 gazillion. We need GitHub.
When it says that it's cloning into, what does that mean?
It's going to make a new directory and dump the index of whatever repository you told it to into that new directory. So it's basically building a new file tree. Okay, wow, I can get some of them. I can get my repo. Huh. Let's try someone else's.
Yeah, let me check my link and make sure it's good.
So maybe it's not Bill. See, I'm so quick to blame Bill. It's terrible. It was one of my New Year's
You mean
resolutions.
I can't use him as a scapegoat right now?
We can't use him as a scapegoat. It's apparently not. It's not his fault. Okay, so the system is not down. Something about your URL. Okay, so I just cloned, I think Chelsea, right? Yes. Okay, so let's take a look at Chelsea's with Git what? Thomas?
Git
How do we
status.
see?
You're cloning this, right?
I just did.
Okay, so you can do a status and should show stuff.
What will it show me?
It'll show you what's in the directory, or you could do a list, can't you?
I can do all of these things. So I can see that it made a Git repo. It made a directory called DAT129_CCAC, which is Chelsea's repo name. See, that's what the directory got called. So Steve asked exactly the right question. What does it do? It makes a directory called the name of their repo in the location to which you ran clone, and then it copies everything in.
So when I make Py2 peer repos and then I copy, I'm pulling from somebody else's and putting it in mine.
You are instructing Git to go to a remote computer and get all sorts of new content and dump it onto your system. So you generally don't want to get Git repos from people that you don't trust. That's not a general rule, because just getting a Git repo on Linux, at least, is not a terrible thing if you don't go in there and start running stuff. I will make no warranties about what happens to files once they make it onto Microsoft Windows operating system. So Git status does not tell us what's been going on in the repo. It just tells me what branch I'm on and if there's anything that I have changed that I have not committed. How do I see the commits? Sorry, get a little cough. Log. So we can see when Chelsea's been working. Nice, you've been committing very well. So we've got these nice, you can see that Chelsea's tried the warm-up or exercises. Look how nicely organized this is. Good work. String formatting warm-up, and then if you miss something. So if I look at this, I think these are two commits that if Chelsea wanted to, you could collapse them into one. I bet there was a little tweak that you made in 10 minutes. So remember, this is now on my local system. I could unplug my network connection, and this is all on my file system.
Question. I might be failing to understand how this works, but so we pulled from their repository, and repository and directory, those aren't interchangeable.
A repository is, by definition, a directory that contains a .git subdirectory. It's a special directory. It's a directory that has instructions for being a repository.
Okay.
So we get that whole bundle, and it gets plopped onto your system at that location.
Okay. And it's a shared location that is on my computer, which I can then push out to their server, basically.
There's no security implications beyond the write operation from the remote. So I'm just being specific in that it doesn't have to be shared with anybody. Chelsea maintains no connection. It's not like Chelsea doesn't now have a magic way to inject stuff onto my computer unless I choose.
Snapshots. So I took it for as it is right now.
Yes.
And I brought it onto my computer.
Yep. And so Git Clone, in the sense that it maintains its connection is that, like we demoed at the very end of last week when we were all tired, a cloned repository maintains the only thing it maintains is the URL of the server or the location from which it was cloned.
At that time.
So at that time, and we get to that by saying git remote, and then the -v for verbose flag will show us that because of the clone operation and the default behavior inside Git, we were automatically provided with a remote computer name and access URL called origin, and literally the only thing that Git knows about the origin is that it is in theory a GitHub repository located at github.com, wherever that is, /C Riccobelli. Is that how we say it? Riccobelli?
Yes.
And /DAT129. So there's nothing magic about this other than it's a URL that can be resolved on the World Wide Web.
So if I just did what you did, I tried to do the git remote, and it says fatal not a Git repository. I don't know what I'm.
It's because you probably cloned it, but you did not yet go into it. So
And how do you go into it?
That's your CD command. So
yeah, I did that.
So run your ls, and you should see that there's now a new directory called,
okay, when I did dir, it didn't have blue, and now I hit ls and it's blue.
Yeah, well, dir is the Windows holdover. So you shouldn't use dir, you should use ls.
Okay.
So now you can cd into whatever you can see via ls if it's a directory.
Okay.
And now you should be able to say ls -a and see that there's a .git inside of there, which means that a Git status should give you something other than fatal.
Here. Everything should be clean. Okay, thank you. I appreciate that.
Yep, and now you can run git remote -v and see where it came from. Okay.
Okay.
So now once it comes down on your computer, once again, the fact that it was cloned, the only implications of that are that it maintains a record of this pathway to where it came from, Mother Earth, Mother Planet. And the other thing that it has is whatever branches I got down. Now I'll bet that I only get one branch at a time. So if I run and say git branch, I bet I'll see master. And I have an asterisk to suggest that I'm on the master branch right now. And I think if I say git branch minus A, oh, everyone do this. Oh, git branch minus A is very interesting. So just like the ls minus A shows us hidden directories, git branch minus A shows us hidden branches. And so the other thing that happens when we do a clone is we have not only do we have a master branch that behaves just like every other local master branch that we've ever used, but we have included a special branch in the background that is designed to reflect the changes that are being made to that parent repository. And it is stored in a branch whose name is, by default, you can name it whatever you want. It, by default, is the name of the remote that it came from, / and then the name of the branch that it's tracking. So this is called the remote tracking branch. Now, Chelsea, can you do a live demo with us?
Okay.
Can we put you on the spot? So what we want to see is, what is the interaction like, deep breaths, what is the interaction like between Chelsea's remote and my copy of Chelsea's remote? And so we want to practice that workflow for a second, and then we'll jump into JSON. So what we want to do is set up a little test. And so what we're going to ask Chelsea to do is make a change and then a commit on your local machine, and then we want to watch it. Then we'll do a push operation, see how it makes it up to the remote, and then I will, and we can all attempt to grab those changes on our local copies. So let's give Chelsea a second to get oriented with a new making change to a file. And if you can prepare your screen so you might share it with us, it'll make the example much more vividing. Vividing, that's a vividing example.
So you want me to share like my spider as I'm changing something? Like, cause I
Sure.
just,
Yeah,
oh, okay.
And then we'll do a push to get it up to your remote.
Okay, so I'm changing like, well, I was working on my code with Eric for the icon.
Great.
So I'll just say, like, I just typed some things in and I save that.
Yep, great.
So then I'll, how do I share like a different screen?
You have to stop your share and then go to share again,
okay.
and it'll ask you what you want to say.
Okay.
Someone's getting a nice clean rug.
Hey, Eric.
Hello.
I actually cloned Chelsea's repo over the weekend, and I got a message when I tried to push. I got like a security thing. It says git push fatal, unable to access the requested URL, denied, something like that.
Did Chelsea give you write access to her repository?
No, so I was just wondering, like, how would someone do that?
There are two ways, and that's a perfect question to ask. So remember the this relationship between the me local and the remote it's a peer-to-peer relationship. So when you said git push, you were engaging in a conversation with the manager of that remote repository, and that conversation went something like, well, who are you? And you said, I'm so-and-so. And then it said, well, I can see that there's a repository there, but you only have read access to this repository. So one option is Chelsea would have to add you as a collaborator on the server, because the server is what's managing that authentication.
Mm-hmm.
If you made a second repository on your local machine that's not managed by a Git server system, it'll let you, as long as that user has write access to that location, will let you do a push. So pushes can be within a computer or across the planet. If you don't have access to write to Chelsea's repository, you can engage with the server and make a pull request, which is a commit that shows up on the GitHub.com interface as a requested commit, and that's a process that's managed by the Git server. So we'll do that in about a week.
Cool.
Okay, so now we've done a beautiful commit. Now run your Git log and see what's there. So we just got changes to icon code moments ago. Now, has anything happened on the remote yet?
No.
No. So go.
Couldn't push it.
Yep. Let's verify this. If you navigate to GitHub.com, can we look at your repository from there?
Can you see this screen?
No. I think you're only sharing that.
Only sharing one screen. Okay.
I can jump over. I will stop your screen share quickly, and so I'm going to do a refresh here, and I can come up and see. Here's master branch, and I can see 8 commits. The last one was 5 hours ago, so we have not gotten these Git icon changes yet. So now let's go back to Chelsea and see the magic. So now let's. So if you were just sitting down at Chelsea's computer, you would want to start by checking to see what remotes are set up. So if you could share again and then run git remote -v, so you can queue out of this list. This list is a program called, this is the queue. Poor Rachel Roth was stuck in here. This program is called Less. It's a pager program, so Q will get you out of Less.
Oh, okay.
There is a competitor program that is called, of all things, More, and they're both paging. They're both common paging. They let you see stuff at one page at a time. Okay, so now run git remote -v, and let's see what. So we want to see who to send this new change to, and so you have the default origin set up. And notice that you have 2 entries, one for fetching, that's a down pull, and then push is the location to which you can send data. And so now if you can run git push ---- help, let's look at the syntax. So the way git push works is, wait, did it pull up something else?
It pulled up a, yeah, like the manual page.
A window. Okay, I must have
a new window.
a different window. So if everyone does that, we won't fiddle with the sharing. But if you look in that man page, you'll realize that at the top, the syntax is the word git and then the subcommand push, and then we have to tell it first where to push to, and then what things to push up, and we specify those with a branch name and a remote name. So if Chelsea jumps back to your command line, let's try that. So what do we want to push? What do we want to push? We want to push, we push branches. We can push commits individually, but that's a rare workflow. We push an entire branch, so we want to push master to where? The name of the remote is?
Origin?
Origin. So we're going to say git push to where? Origin. And what? Master. Good. Now, ooh, look at you. It's automatically authenticated. You must have done this before.
Yeah.
Great. So look what it said. 10 objects. It compressed them it wrote them to the server. All 8 were accepted. All of the changes were made to 2 local objects, and it tells you where and what branch and the first 4 digits of the hexadecimal version of the hash code of the entire tree up to that point. So now, this is amazing. So with that one command, now when I go on the internet and refresh Chelsea's repo, I should see, look at this. Look how cool that is. Changes to icon code, and I can see line by line the changes that Chelsea made. These were all added because we copied a function. So those show up in green. Chelsea was tinkering with how to turn this into a loop, and this line was deleted along with that comment. Look at that. Look how cool that is. That's powerful. Now, can I see that if I'm local? So if I go git log, can I see the most recent commit should have the name changes to icon code? I do not have it since I have not asked Git to sync those up. And so this is where we pause and we chat a little bit about tool use. So remember how I said that the remote or the your local repository has the hidden area or the hidden branch called the remote tracking branch? Well, there are 2 ways that we can move data down. I'm going to mute everyone just so I can get a little less vacuum for a second. Okay. Let's do, so here's our remote, and here's local. What I want to do is make this a little clearer. This is another one of those cases where there's a whole lot of Stack Overflows that tell you to just do a pull and be done with it. That is not how we learn how to use a tool effectively. So in my Chelsea, in my version of Chelsea's repo, so my git log, I'm going to do a shorter version, git show branch. There it is. Okay, so on Chelsea's got on my local repo, so this is repo, we're looking, this is a blow up of the index. So this is index only. So I have a master branch, I have Chelsea's master branch, and then I have a hidden branch called origin/master. And this is for your notes. It's very important. If you can go into an interview and talk about remote tracking branches, they'll say, oh, this person knows how to use Git. This is designed to always be in some codified relationship to the remote state, the state of the master branch on the remote server. So we will never edit and tinker in the origin/master. And if we check out this is where we had that weird message. I remember what it says. You were in a what state? Detached head. So if I come here and say git checkout origin/master, because that's the name of the branch, look what it says. Git checkout origin/master. Note, switching to origin master. You are in a what? A detached head? Who took my head? You can look around, make experimental changes, and commit them. And you can discard any commits you make in this state without impacting any branches by switching back to a branch. If you want to create a new branch to retain the commits you create, you may do so now by using -c with the switch command. Or undo this operation with -. Turn off this advice by setting config variable advice.detached head to false. So what this means is I can say git log and I can still see just the commits that are on the remote. Now you're saying, okay, great. Why would I want to chop my head off? It's because what we normally want to do is to be good Git users, we want to be careful about our versions. Once we start working with other people, this will not be trivial anymore, and it will not seem like an extra step. It will seem like a critical step. And this is probably what a lot of the GUIs do for you, because it's so important to maintain a clear idea of which things are in what state. So let's just name Chelsea's master commits A, B, C, and D. So Chelsea has A, B, C, and D. When I cloned it down, I got a remote tracking branch and a master branch that were identical to Chelsea's master branch on the server at the time, which was only A, B, and C. So on my local system, I look like this on both my remote tracking branch and my master. They're now completely synchronized, meaning they have the same commit history. But what do I want? I want that last commit that Chelsea did. I want D. So the bad advice on the internet is to say git pull origin master. And what that will do, what that command will do, is take everything that's at the remote origin and automatically dump it into the remote tracking branch, and importantly, automatically run a merge with my working directory's master copy. So let me zoom out a little bit. So let's make this clear. Where can we go? We're going to go down to the bottom. So this goes in notes. Absolutely, this is critical. I know lots of people that have been working on Git for years, and they couldn't really tell you the difference between these two fundamental operations, but they're startlingly different. So when we do a git pull, and then we give it a name of a remote, followed by the name of the branch we want. This is asking Git to do first. It is doing a fetch to remote tracking branch. And invisibly and automatically, it is also running merge into whatever branch you're on when you run this command. So merge from remote tracking branch to current branch, which in my case is master because I haven't switched out. So git pull has this automatic merging, meaning it will make them be the same, and it will yell at you if it can't figure out how to make them the same. So this says unify versions to match the remote tracking branch and your current. Now the problem is we usually want to do this carefully. When you start working in a professional workflow, you are often in a state where you might be working on the same things and you want to do the merge manually, or at least have that capability when things get hairy. So what we actually want to do most of the time, and I'm going to encourage you to do as you practice Git, is instead to say Git Fetch. So only doing one and then doing two manually later. So we would say Git Fetch, and then we give it remote, and then branch. And this will automatically update. This will sync remote tracking branch only. And then we have the option of merging to any other branch we want. So then manually, user can merge in changes to real branch. This will take time to get used to. This is a first exposure, and these are the fundamentals, and they're never going to go away.
What's the first bracket say? Git fetch what?
Remote, the name of the remote. So where do you want to fetch from? And what branch do you want to fetch?
So then it just puts it into the same directory that you're in when you're running the Git fetch.
It will
But
all be, it's all in the same
depositing
directory.
it. Right, it's just depositing it
in the invisible place of the remote tracking branch that you only interact with your head cut off.
Right.
So a Git fetch has no impact on your working directory by definition unless you happen to be in a state of having your head chopped off. So the workflow that we're going to do now is a Git fetch and then a Git merge as two separate commands. And when you feel really comfortable with how to do that, you can run Git pull, and you'll always know what happened, because the day will come when you will do a Git pull and there will be a conflict and you'll get flustered unless you realize all of a sudden why is it upset, and suddenly Git status has all these exclamation points everywhere, and you'll feel like you've been sucked into a horrible nightmare. And no one likes nightmares. Well, I suppose most people don't like nightmares. So let's try it. Everyone do this with me. You've got to do it 100 times. So let's go fetch.
Hey, Eric,
changes.
how do we get out of this detached head state? Like, I can't type anything in because I just hit that Git, like I was following along with you, and it's like I don't have my thing anymore.
You don't have your prompt?
Right.
Try hitting Q for quit to see if you get out of the pager.
Okay, that worked. Thank you.
Okay, and now you probably want to go check out your normal master again. And then your head will come back. The head is a pointer to the tip of the current branch. So now that we're at Git branch master. So what I'm going to do is I'm going to open that file that Chelsea had edited so we can watch the glory of Git in all of its mighty splendor from the text file. So here's peer repos, here's Chelsea and icon module. So we can tell from online that what Chelsea was editing was the file called icon_code.py, which I will open. And so we can see that this is still the unchanged version because Chelsea had a bunch of variables that she was initializing. So this is still the unmerged version. So we want to see that this will stay even when I do Git fetch. Where do I want to fetch from? I want to fetch from origin. And what do I want to fetch? I want to fetch all of the commits that I don't have on the master branch. Am I going to see any changes yet over here? No, because I'm on my master branch, and this will only get moved to my detached head branch.
Right, and you're only doing a fetch.
Yes. So look what it did. Enumerating 10 objects, 10 made it down, total of 8, 5 deltas. We didn't have any lost. And look, branch master has now this pointer called fetch_head has been moved along, and it's been moved along the branch on origin/master.
Deltas are changes, right?
Yep, exactly. So now watch. If I check out origin/master, we get that crazy thing where everything in our working directory changes. So watch that, and then we'll do the final merge, and then we'll move on to JSON. So this is something you're going to have to tinker with on your own because we're moving fast tonight. So get ready for the magic. So we're going to say git checkout my remote tracking branch, origin/master. I'm clicking. I'm doing no funny business here. Huzzah. We said huzzah. What's this one? Oh, I wonder if this was somehow delayed. Okay, well, we have access to this one now. I'm not sure what Sublime did. This one should go away when I say git checkout master, because master doesn't know anything about this. And now look, previous head, this is so cool because we just did the fetch. Look, your branch is behind origin/master by 2 commits and can be fast forwarded, or use git pull to update your local branch. It even tells you to do this. We disagree, the Git people and I disagree. So you can see this goes without saving. I now have, this is back to its original state. And so what it's meaning by fast forwarding is, let's go here. So now we've got, so now here's our local. So now our remote tracking branch has D, and I think it actually says that there's an E too by 2 commits. And so when I checked out master, it did a comparison because it knows the origin/master branch knows that it has a linked connection to the normal master. Those are stored inside the Git, and you can study how that happens, and it's quite interesting, but you don't have to know exactly how it works. So it's saying you can fast forward, meaning your current pointer called head points to the most recent commit on your current branch. And what it's saying is there are no problems. I don't have anything complicated to do. All I have to do is append the changes that are on the remote tracking branch to here. There's no conflicts to resolve between any of the files. So when I do a git merge, so now a merge, can everyone see my arm? A merge is a pull into where you are. So we stand where we want the changes to go to, and we say merge, and that means go to the place I tell you and make where I am just like it. And if you don't know how to make it just like it, it'll throw up a conflict and you have to resolve them manually. So you check out the place to which you want the changes to go, and then you say git merge, and then you tell it which branch you want to synchronize with where you currently are. So we say git merge, and then we give it the name. See, we just chopped off the head. This is not a good drawing because you've got a head here. So we say git merge branch name. So what's the branch we're going to merge to? A local operation only? What do we want to make the changes in our current branch look like? We wanted to make it look like which branch? Who's got the changes we want? The special branch. Was that Thomas?
Yeah, I was going to say it. You have to. It's back on the main computer, or would have been on Chelsea's computer, so you would have to fetch it again or pull it
No,
again?
it's local. When I checked out Git, this is a local operation. When I say Git checkout origin/master, this is a local branch that is hidden inside of your Git repository called origin/master. So when I did a fetch, the fetch is network. Merge is, and for our intents and purposes now, is not a network operation at all. So fetch means go to wherever I tell you to. If it's over a network, then by all means, go to the network. Okay.
Master.
We're on master. What do we want master to be like?
Origin.
Origin, not origin. Origin what?
/master.
Origin/master. That's the name of the branch. Remember, we can always figure that out by typing git branch -a and see that git branch -a says O-V. Oh, that's because I'm in detached head. That's right. So I got my two branches, master, and I'm now currently viewing origin/master. So I'm going to go to where I want the changes to be, and then it's reminding me that I'm 2 commits behind origin/master. So I'm not going to take its advice because I've already got them locally. It wouldn't hurt. It'll just do it again. I'll say git merge origin/master. This is a big deal. This is the meat and potatoes of Git. Look, one file changed. We added 150 character line things. Created mode 100644. So now I can see git log. Look, 1845. That's what you had, right? Parent 1 commit. Come on, give me the actual timestamp. 27 minutes ago. Yeah, that makes sense. Look at that. And so now when I come into my editor and do an F5 on this, for some reason this guy is not updating automatically. Edith, peer repos. There it is. So Chelsea made changes. Chelsea pushed up. I fetched to my local system, and then I merged manually. That's what we're going to start doing with each other's code starting next week. So practice this week. Questions so far before we break? That was wild ride. This is cool stuff. Remember, git fetch, then git merge.
So you don't have to push.
In my case, I was only receiving work from someone else. Chelsea did the pushing up to the remote, and then I pulled down from the remote, never interacting with Chelsea's local computer.
Okay.
So if we had to draw our picture more completely, we would need Chelsea. We need a Chelsea local here. So Chelsea local Chelsea's working on ergonomic keyboard, so the keyboard is wider than the monitor. So Chelsea local. So Chelsea would have A, B, C, D. And so Chelsea pushed the D up to the remote by automatic configuration called origin, Chelsea did a git push to where? Push to origin. What do I want to push? In Chelsea's case, Chelsea pushed all the commits on the master branch. So then that was step one. And then this is not where the push was. So then we did a step two was git fetch. Now git fetch by default will, if you just say git fetch, it will infer whatever your, if you only have one remote, it will use that remote. If you only have one branch, it will use that branch. So git fetch is legitimate expression, but we want to get in the habit of not just using defaults, because we want to know how the tool works so we can figure out when the default is not the right use case. So we'd say git fetch, and then we said, if we just say git fetch from where and what, then we know exactly where it's going to go. The fetch operation will always go to an RTC, a remote tracking branch. And then step three was we could look at those changes. That's why it says when you're in the detached head, it's like you can look around. What they mean is before you accept all the changes that came down into your working directory, you can see them before you do the merge, which is handy. So step one was push, step two is fetch, step three is merge.
Like local computer.
Sorry, come again? I heard the word computer.
Is push only from your local computer then?
That's correct. Well, it's from one repository to another. Our version here is from a local repository to a remote. But you could push to another repository on your own system. It doesn't care. It just has a different location. The github.com happens to be a server, who knows where. This is the silence of having just eaten a very large meal and needing to rest. So let's take a break till 19:30.